Good day, Professor Van here. In this lecture, we'll be discussing actuators. So, what exactly are actuators? The textbook definition of actuators are components of a machine that is responsible for moving and controlling a mechanism or system. We have a few examples here on the right side of the screen. We have a linear motion that translates into rotation motion, which then controls a valve of a tube. It allows or blocks the passage of water in the tube. And then we have an octopus arm right here. This is one of the more advanced technology which needs more advanced actuators. So as you can see, it is quite strong. It can grip a metal cylinder. Now, actuators can be categorized as electric motors, hydraulic systems, pneumatic systems, and any other system that can apply force. In this video, we'll be discussing pneumatic systems, hydraulic systems, and electric motors. So to start with, pneumatic actuators. These are its advantages. It's relatively inexpensive, simple to install and troubleshoot, clean operation, ideal for food application. This is because even when pneumatic actuators leak, it is made of air inside. So when air leaked, it is relatively clean compared to liquid. Now these are its disadvantages: variable speed and positioning, and high accuracy is difficult. This is due to the compressibility of air. Compressors requires maintenance. Air filters and condensate lines require maintenance as well. Now, maintenance would entail downtime. This would lessen the efficiency of our machine. This is one example of a pneumatic actuator. This is a single acting cylinder. So as you can see, we have our piston right here and our control. When we push the button down, air would be pumped into the cylinder, compressing the spring, and as you can see, it moves the rod outwards. Now, if the button is unpressed like this, air would be released through this hole right here, and the spring would push the rod inwards. So it's that simple. So now we have our double acting cylinder. Instead of having a spring to control the inwards motion of our rod, we can now send compressed air in both parts of the piston to control the movement of our rod. So if we want to move our rod outwards, we need to send compressed air right here. And if we want to move our rod inward, we send our compressed air over here. Now, as you can see, here in our button, this is where our compressor pumps air from. And then air would be allowed to leak. And these two holes, 1, 2. Okay. So it's a relatively easy operation. Hydraulic actuators. Hydraulic actuators, on the other hand, instead of relying for air pressure, it now relies on liquid. So it uses fluids for its operation. The advantages of hydraulic actuators is that it's meant for large size robots because of its strength, works using incompressible oil, so it affords more control and accuracy in movement as compared to the pneumatic actuators. But the downside is that it's dirty and messy to operate because as it leaks, it will leak fluid. Sometimes the fluid used is oil, so it's actually quite messy. Filters, lines, pumps, and oil all require checks, changes, cleaning, and replacements. So these are the routine maintenance that will be done for our hydraulic actuators. Again, it decreases the efficiency of our machine since maintenance would entail downtime. Here is a picture of an actual hydraulic actuator. It looks similar to our pneumatic actuator. The principle behind them is actually quite similar. So we have here our example. First, a pump will send the fluid down to our cylinder, so it pushes the rod upwards. And then when the button is released, the fluid would then be pushed by the rod via the spring, and it will go to the fluid tank. Once we want to send the rod outward again, the pump would send the liquid onto our cylinder again. There. So the operation is quite easy to understand. Let's move on to the electric actuators. Now, electric actuators have these advantages: capable of moving robots with high power or speed, perfect for small robots and precise applications, greater accuracy and repeatability, programmable speed and stop positions. And the disadvantages are: to increase torque, a large and heavier motor must be used, which is costly. Output power relative to weight is low, and it's complicated to install and troubleshoot. Now, obviously, the most costly system is the electric actuators. Now, this is an example of an electric actuator. If you look closely, there is a motor inside. The rotational movement of the motor will translate into a linear movement of this red tube. The red tube is fixed by this yellow nut onto this rod, and when the motor rotates, the red tube will either go outward or inward depending on the direction of the rotation. That's it for actuators. I hope you've learned something. See you in the next video.